Hello everyone, I am Pedro Conde. I've been working in BigQuery, well, mostly GCP, but all focused in BigQuery for more than 5 years now. I've been like helping different companies to reduce costs in BigQuery regarding to bulk storage, uh, the compute part also most of the time. So yeah, I'm going to do like this talk about FinOps and try to give you some examples, some tips for trying to reduce everything, all the BigQuery spend, which is usually the biggest in GCP in my experience. So that's a quick intro so you get to know me. I want to start going first with the general approach of how this problem, how this ecosystem works. Basically, the query is decoupled by design, as you may already know. You have the computer, you have the storage. In my experience, most of the time, the computer is like the biggest pain in the BigQuery billing. Like it's around 80 to 90% most of the time of the entire cost, while the storage is around 5, 20. It just depends on the client, but this is usually how it works. And just to give you a quick intro, just to touch base, these other secondary lines, these are not as important, but I think it's just worth it to mention it, that we're charged for many other things, like for example, the inserts, both the streaming and the storage read API, not the batch ones, BI engine, and a few more things, as you can see here, basically, that might inflate the bill at the end of the month, that you should be aware that these things are just fine. You're just doing the right things here too. I won't like deep dive into this, but just to mention all these things here also incur cost, might be costly sometimes, and you need to be careful when trying to choose the best option for your workloads, for your pipelines, and just be conscious when basically doing all these actions here in BigQuery. This is a quick note again for this same problem, this streaming part that is also incurring cost to the BigQuery, to the BigQuery bill. Basically, I've seen a lot of clients trying to go always streaming because it's faster, so that's better. Let's just go streaming. It's super fast. We go like 2 seconds latency and everything's in BigQuery, but that is not always useful. Like sometimes, indeed, most of the time, you don't need that super high frequency ingestions to BigQuery, and those are costly. As you can see here, you're paying around 1 cent of a dollar per 200 megabytes. So my first recommendation here is just like go to your pipelines, go to your workloads, and try to realize, define like some SLAs, and try to define if you really need streaming inserts or if you can switch to batch. Because a good thing about batch ingestions in BigQuery is that those are free. So we need to use them more, in my opinion, if we don't need super high frequency. Like I was estimating like batch loads can take around 1 minute to 90 seconds approx. You just need to load it into GCS and then from GCS to BigQuery. So keep that in mind. And if you want to have like a higher frequency instead of going to the legacy streaming approach, which is the most costly one, you can just go for the storage write API. Google recommends that. It's super fast also, and it's just cheaper and better. It just handles everything better than the legacy streaming API. So keep that in mind. And yeah, this is basically the same. A few metrics about the latency. You also need to be careful about the hard limit. You can just do 1,000 loads per job, per table, per day. So just be careful with that. If you're hitting that limit, you should switch to the storage write API. If not, the batch is just fine for you, and then you can just proceed with the batch. And now that we have talked about, let me go to the next, about the inserts, everything about that, we can now switch to the second most costly part of BigQuery, which is the storage. Just high level in storage, you have 2 different modes. You have the logical model, you have the physical model. I mean, for logical, you're charged just by the bytes you have stored in BigQuery, and that's it. Plus a rate that BigQuery charges you monthly, and that's the entire thing. But if you want to go physical, you have to pay for the compressed data, and you need to be careful with that because sometimes the compressed data is not as small as possible. Like BigQuery uses this format called capacitor, and sometimes it's not good enough for compressing your data. So you're going to pay more for the physical model. And just you need to take into consideration that also time travel and fail-safe data cost money in the physical model. So you need to be careful about that. We have all these high level, the 2 billing models. And I want also to touch base about the 4 different types kind of storage we have in BigQuery. The active one, which is for data we use every day, basically. It's just data that has been modified in the last 90 days. Then we have the long term. It's just like the other way around, just historical data that we don't touch that much, and that is cheaper, half the cost. And then we have time travel and fail-safe, as I said, that are not built in the logical model, but that are built in the physical model. So just be careful with that and choose wisely which one is the best for you. Here, as I'm saying, logical is the option by default, little bytes plus the rate, and physical with all the other thing like the time travel, failsafe. I would recommend to go to the information schema tables usually and just check those tables and check your table, how much is it in the logical model and the physical model, and just compare everything just before going from one option to the other option. Because if I'm not wrong, it takes around 7 days to be able to turn it back to the old version. So don't make those errors and just calculate everything before, and then just choose your model wisely. This one trap that I've seen in a lot of clients, basically having materialized views or tables that you trunk and load a lot of times every day, and that might cause a lot of chaos in the physical model version. Because as I'm saying, in the physical model, you're paying for also time travel, which is basically all the snapshots you take, all these delta incrementals you have in the last 2 to 7 days, and for the failsafe period, which is 7 days. So if you have tables that you're going to update a lot, like maybe, I don't know, 10 times per day, whatever, even more, or you have materialized views that will also incur costs while trying to update the view when the source table is changing, you will go to the logical model always. Like, again, this is just like one example. I've seen bills up to $3,000 per month only for one table of storage, because that table was just like truncated and load every 10 minutes, every 5 minutes, or for materialized views, just the same. So be careful with this. This is a huge trap for most people, and you don't realize about it until you see the bill at the end of the month and see all that cost. So this is a good thing to take into consideration. If you have tables that you're going to update a lot, just pick the logical model. That's just way better. And a few levers that you can use to reduce storage costs. Easy, I guess you all already know, but you can set partition expiration days in your time series table. So just partitions expire themselves when a certain days passed. You can also set expiration times at the table level for example, for snapshots, for table that you just need for a few days or a few months. You can just set that expiration time, and so it just deletes itself after that time has passed. The third level will be, you also need to consider that maybe not every data needs to go to BigQuery, but you can also leverage Big Lake and everything like that. Like right now, it's very like common and popular to use these lake house approaches, etc. So that might be good also for reducing storage costs. Like if you don't need to store data in BigQuery in the raw layer list, you can just leave the data in the GCS and query data from there. And then you can just have your silver and your gold or whatever you're doing in your pipelines, but those stages in BigQuery and the raw in the Big Lake in the GCS, which will be sometimes even cheaper than the BigQuery's cost, and you're not going to duplicate the dollars you're paying basically for storing the data. And the fourth level, easy again, just as I said, check everything in the information schema tables. Just monitor everything, compare your bill, the logical and the physical, and just choose wisely and pick the best one. Most of the people are not doing this because you don't care about storage that much, but I can tell you can save a lot of money, a few thousands, just by doing this properly. Pick the best model and just go for it. And now let's just go straight to the important part, which is basically the compute, where almost everyone spends the entire money in BigQuery, which is everything that we do when running queries. You have like two models here. You have like the on-demand model and the editions model. On-demand is basically you're just paying for every byte that you scan, plus the rate, which is $6.25. It depends on the region, but most of them are like this. So here you have like two different levers to reduce the cost. First is reduce the bytes per query. You can do partitioning, you can do clustering, you can do column running also. A few other things that you can just do to reduce the bytes per query. And lever two is to reduce all the repeated scans. I don't know, like for example, creating materialized views, leveraging BA engine, and a few more things that you can do here. But those are like the two levers that you have in the on-demand part and that you need to consider and think about it. Editions mental model is quite different. Here you're just charged for the slots hours you use, plus the rate per slot hour. That will depend on the edition. It's just different depending on the edition that you pick. Easy, it's better sometimes. Basically, I'm going to explain that later, but this is super simple to understand. You have a slots hour, you have a rate, just combine those, and you have like how much are you going to pay? And these a few questions I added here, basically for when one is better than the other. Generally, because this is not like a rule, you just need to figure it out yourself. But most of the time when the workload is steady, you will like to go for editions, because the bad thing about editions is that when it scales up, it does that in 50 slot steps, and that it will keep like that for 1 minute. So you might be paying a lot more than you need for your spiky pipelines. So if your pipeline is steady, you can just switch to editions, start thinking about commitments, baselines, and you will save some money, I'm sure. But if it's spiky, to have in the second rectangle, most of the time on demand is way better, because for on demand you only pay for the byte scan, so you don't care about scaling up and then down and all that 1 minute window that you have there. So just to mention that here. Second question, you can just, if you can forecast like the growth of your company, of your pipelines, that can be also very useful for doing all these commitments, 1 year, 3 year commitments, to reduce the number of dollars you're going to spend in these editions compute. Third question is basically, if you have multiple teams, you can just share all the idle slots between them. So you're going to leverage them better, because the principal pain point about editions is just not using the slots, scaling up and then staying there for 1 minute, 2 minutes, whatever, without using those slots, and that will charge you more. So if you have multiple teams and they can share all the idle slots, that'd be perfect for editions. And then the fourth question is very simple and straightforward. If you're all the time hitting the 2,000 slots ceiling, you might want to consider moving to editions. It just depends on your scenario and your company, but that's like a good thing to start. If you're hitting this 2,000 slots ceiling, you just need to start considering and doing like a few calculations and checks. Quick summary on demand wins. As I said, when the workloads are very spiky and unpredictable, when you're also early in the adoption phase, so you don't know how you're going to be in 5 months, 6 months, 1 year, then you should go to on-demand. But it loses if, for example, your workloads are like very steady. You can just make them be steady and predictable, because that way you can just start doing commitments, start paying less money, start really using those auto-scaling capabilities that editions have. So keep that in mind. Then we have these two tools, I can say, in the BigQuery tabbing in GCP, that are also very useful. You can use them when you reserve some editions, when you do some reservations. You have both the slots estimator and recommender to just give you some insight about your reservation. The first one will just give you, recommend you like a baseline and auto-scale config. You can just check everything there, and you can just monitor what have you purchased and see if you're good. If you're just like overestimating your usage, or maybe if you're super low, you can just check everything there. And the recommender, you need like 30 days of data, and BigQuery will start giving you some hints or kind of like outputs, where you can just test how your pipelines will behave. If you have less slots or more slots, you can just compare everything and check everything there. And these are the 3 different types of editions, basically: a standard, enterprise, and enterprise plus. A standard is like the cheapest one. It has like a top in 1,600 slots. It's not recommended for production because you can't do column level security. You don't have the maximum concurrency target, and a few more things that are super useful and I would say compulsory for production. So standard is fine for doing tests. It's the cheaper one. So for lower environments, it's fine. But for upper environments, for production, you go for the enterprise or enterprise plus. Enterprise is just like the default production tier, I would say. You have like the full set. You have column level security. You have all these maximum concurrency target features and everything. It also supports the baseline, which you will always pay for the baseline. You always have these 50, 100, 200 slots active there for you, and you can share them between reservations. They're called like idle slots. And then the Enterprise Plus, which is basically the same, but with a few more functionalities like the Azure workloads and a few more things. I wouldn't go for that one most of the time, so I would just keep on the Enterprise. It's usually the go for option for most of the companies. So just to let you know, this is like a few rates, like how much do you pay for the different editions. Easy, just for information. And then a quick tip that I've been using in different companies, also doing like some, I call it reservation topology and dynamic assignment. Like you can just have one project, and in that project, you don't need to commit to only one reservation or to use on-demand or reservation. You can do a reservation and have no assignments, and then you can just redirect, like do like some kind of load balancing for your pipelines using that parameter you have there on the right side called reservation. You can just run that in your data form code as a pre-operation in the main body if you want, and that will just make that your data for actions, all the jobs that are inside of it will use that reservation. So that was very useful for me when I was trying to do tests with reservations and trying to be sure if I'm fine, if I'm not fine, if I want to go up or lower. I would do this pipeline by pipeline, do like a step-by-step migration and start checking metrics. So I don't start big and then like it's just to reduce costs and doing a few tests. It's super useful. I think most of people doesn't know about it. Like you don't need to commit to on-demand or editions in your project. You can just have both and have my queries running on demand and my pipelines, the more critical ones, running on a reservation that I did for critical pipelines and the other one on another reservation for a standard pipeline. So this is very useful and a huge tip for people to start doing tests and not be afraid of spending too much money in reservations from the start. Same here. This is how basically the slots works. When you have a reservation, you're going to first consume your baseline slots, then the evil slots from different siblings reservations, and then the autoscaler slots until you hit the max that you have defined. You can define different scale options that you can see there on the right, baseline and idle slots, or just use autoscaling and baseline, or just use idle slots. It will just depend on what do you want to do. If you want your build very predictable, if you don't care about jobs queuing up and taking a bit longer, you have all these options. All of them are worth it. Just investigate all these 5 different scenarios and pick the best one. A quick technique here that is also very useful for you. When you're trying to move into editions, the first step is always define all the SLAs. Like I need to know if my pipeline need to run at this time, if it can take maybe 10 hours to run or 2 minutes, because most of the time we just migrate to editions and that's it. I mean, I don't change anything. But I think the first step should be always to first define all the SLAs, have everything noted down, and then you can know if I can just redistribute a few jobs and make them run at night or here, because here the pressure of the jobs is just lower, so I can just create a very steady flow of compute, which is better for edition. So this, to me, like the first step, do this workflow smoothing. And also very similar to that one, faster is not always better. Like this is also a thing that happens in a lot of companies. Like I don't want my pipeline that needs to be ready for tomorrow 9 a.m. to run in 2 minutes. Like if it takes 1 hour to run, 2 hours to run, maybe it's fine for most of the cases. So you need to define again the SLAs, divide critical pipelines and non-critical pipelines. And for example, this is a test that I've been doing in different companies to save a lot of thousands of dollars, basically. I was defining like a very low max slot and I started playing with that. Like I was using the reservation parameter, as I told you later, with a very low max slot and trying to make the curve, like flatten the curve. So I'm using every time all my reservation, even without scaling or with baseline, but this will make you save a lot of money. Because again, the huge pain, the biggest pain about editions is that sometimes you scale out super fast and then you stay there for 1 minute and you're not using the slot in that minute. So if you flatten the curve, if you're always very steady, very low, I'm sure edition will be better than on demand. So this is a huge tip that I give you, and this will most likely be very useful. This is to let you know, coming soon, fluid scaling. We'll just set this in the Google Next, I think. This will solve all the problems about the 50 slot step and also the 1 minute minimum slots running when you scale up. So this is going to be a huge thing that I want to try. And this will be very useful for spikes, basically for super short jobs that run in 1 minute and then go down. Well, less than 1 minute. This will be like the best fit, and you will see a lot of savings using this fluid scaling. 5 compute techniques, optimization techniques, super fast here. Easy, the limit myth. Limit doesn't save any money. Like you can just do the query and then add a limit and you won't save anything. Limit just limit the number of bytes you're showing to the user, but you're computing everything on the background, so that doesn't save any money. And please don't skip the dry run. That's very useful. It will tell you how much are you going to spend, so you can be very predictable and not running $1,000 queries or $100 queries that you don't want to run. First tip is that one. Second, again, only select what you need, because BigQuery is columnar. So if you select 2 different columns, it will be cheaper than doing a select star. So don't do select star, never. If you want to see how a table looks like, you can go to a table preview in the BigQuery UI and check everything there. That will save you a lot of money. This is very easy again, and everyone says this, like, just filter early. I don't want to just get all my data, all the big data, and join that and start doing things, and then at the last step, just filter everything. I want to filter first, get this big data reduced to a smaller chunk, and then do all my joins. And again, this will reduce also a lot of money, because you still don't need to spend that much cost in shuffling, joining, etc. Table sample system. I think most people doesn't know about this one. Also very useful if you're doing some dev work, testing. You can just add this table sample system and 10%, 1%, whatever, to your table, and this will reduce the cost. This will just do some block pruning and show you just a 10% of the table or a 1%. So it's very useful when you're trying to test with new logic and doing new dev work. You can use just this to reduce a lot the compute you're consuming. So keep an eye on this. Partitioning, again, it is everywhere in the internet, in all the different documentations. You need to partition properly. Also add the required partition filter in your tables, because those big tables we have in the silver, for example, layer with all the historical, etc., we can just avoid a chaos with people doing a select all in that entire table, just adding this required partition filter. So that's a good tip that I give you. Always add this required partition filter on big tables, because we don't want to create chaos by running a huge query on a huge table, basically. Also be careful with the 10K hard partition limit, and a few more things, like, for example, don't use shared tables, because most of the time that is just worse because of the metadata that you need to handle when querying them. So go for partitioning the tables, but not reach the 10K limit. And this one thing that I found out working for Elbin and other companies in the past, like the 10 gigabyte guidance for the partitioning is not like a law, it's more like a estimate. Like, for example, in all this medallion architecture where you have the bronze, silver, and gold layers, silver and bronze, for example, are very predictable because they're only queried from, for example, bronze from silver and silver from gold. So you can really do some good partition planning here, even though the partitions are super small. For example, we're having like nearly real-time pipelines running every 10 minutes, 5 minutes. So I can partition these tables with very small partitions, like, for example, 100 megabytes size partitions, and be super cheap and super optimized, because I don't need to scan a lot of partitions. Like Will was saying, this 10 gigabyte guidance, because if you're querying a lot of partitions, the query will take longer, because you need to handle every partition's metadata. But if you're going to just scan 1 or 2 partitions every time, which is what we were doing basically, if you were trying to ingest real-time data or near real-time data, having a small partitions is very good, I would say, and it will save a lot of money. So take that into consideration. Again, clustering, not much to say here, but be careful with the order. If you cluster using field 1, field 2, and field 3, you need to use the same order in your query, in the word clause. So you really benefit from all this block pruning that we do with clustering. This is to let you know, like, medallion architecture is very useful for clustering and partitioning, because you really have a predictable usage pattern in your bronze and silver tables. You know how you're going to query those tables, and you can just treat everything accordingly. So I can partition my bronze table by this field and cluster by this field, so my silver queries will just be super cheap. So if you have this type of architecture, just review all the bronze and silver layers and just make them be partitioned and clustered by fields you're using in the upper layer. And that's it. This is also very important. And again, most of the people is not taking this into consideration. You can apply functions over the partitioning or clustering fields, because you might break the pruning. Like you want to compare fields in the raw format and not add cast functions, etc. Because if you're doing that, you're going to break the planning and you're not going to save any money. So be careful with that. Always comparing the raw format. If it's a, I don't know, for example, they're integer or a string, don't apply these cast functions or similar because that will break the planning. And same with this thing here. I've seen a lot of companies, a lot of people doing this CTA at the beginning, CT, doing set search range equal this, and then I use that value in the where clause. That will break the pruning too, because for pruning partitions and clustering and blocks in the clustering, BigQuery needs to know before the runtime what is the value, so it knows where to go in the storage and pick the partition or the clustering. So you need to declare variables. Those are like super important. You need to declare the variable first, and then use that declared variable that was already computed to do partition planning in your tables. So do not use dynamic variables. Do not use CTEs in your data form code. Just go for variables and do the partition planning properly. I've seen most of the people failing in this, and you can save a lot of money just by doing this right. This is like the same. In the joins, you're not going to do partition planning because the joins are not pre-compute. So that's like a common misconception. It will save you some money if you're going to additions mode because it will just take less time to shuffle things and join things, but that's it. And also, this is an important thing, data types matter. Like some types are just cheaper than the other. So you need to be aware of this and trying to pick always the best data type for your where clauses, for your columns, and that will save you a lot of money most of the time. So be aware of this. Also very important, most of the people doesn't know about or doesn't consider this because for small tables, it's just fine. But if your tables is like too many terabytes or even petabytes of data, the logical bytes of your type will be very important. So take that into consideration too. Search indexes is just for trying to enhance the searches in strings or JSON format, basically. It will both accelerate and save you some money. So if you have huge JSONs or huge row strings, use the indexes to try to reduce the cost. And then we switch to the monitoring and observability. I usually use 3 layers, basically, that I can show you here: preventive, native GCP, and my custom layer. 3 of them. Preventive is basically, for example, trying to set a maximum byte build on every scheduled query I run, on every programmatic call. This is also very useful. Even in the BigQuery UI, you can just define this limit, so you don't incur more cost than you want. It's like a safety net, basically, for organizations. So it's also very useful. Try to use this every time you create a programmatic call, a scheduled query, and this will just fail your query if you exceed that limit. So very useful to have this kill switch here. Custom quotas, again, this is like kind of the same, very similar. You can define a custom quota for your entire project or for every user. So every user can spend more than, I don't know, $100 per day. Also very useful to have these strict lines in the cost part. So you have predictable billing at the end of the month, and you can be like notified if something is happening with your query usage in one day or with this certain user, because this guy is just doing love queries to select all in one table. So you can just prevent that and having this limit and having this guy to ping you if he wants to keep querying, and you can just analyze everything and do like some just like analyzing everything of the queries and be sure if everything is fine or he or she's doing bad things with the data. So also very important in the layer 1, the preventive part. Layer 2, just use the native GCP tools that they have. You can just set up different cloud billing budgets to alert you when, for example, we are more than 50% of the predicted cost for today, or 90% or whatever. Also very useful. You can also set up different actions with this. Like whenever I reach the 90%, I send a message to PubSub, and I'm going to use this PubSub message to stop all the scheduled queries, for example. You can just do like different actions, or sending Slack messages, or sending messages to Teams. So it's very useful to have these budgets, and I would always advise to set up budgets and alerts. You can be alerted when something odd is happening. Also, having enabled the cost anomaly detection is very useful. It's like a new feature that GCP introduced. I will tell you that there is like some anomalies in your cost in the entire GCP, not only BigQuery, but it's also worth it for BigQuery. You also have here BigQuery monitoring page. Easy as you all know, you can just go to the monitoring page, operational health, resource utilization, and just check everything. Is very useful when you want to audit your jobs and know how much are you spending, how much are your jobs taking. So just take that into consideration. Then you have cloud monitoring metrics. Same, you can just go to the monitoring console and start looking at metrics for your BigQuery jobs and queries. Or you can just go to the BigQuery admin resource utilization chart, which is very useful basically for additions. It will tell you how much are you using, if you're above your limit, if you're just hitting the max slots. So those three are three pillars, in my opinion, when you want to use the native GCP tools to just monitor everything regarding BigQuery. Log-based metrics, again, also very useful for most companies, and almost no one is using this, I think, in my experience. You can just define different metrics using different cloud logging logs, and other people are doing actions based on that. Like, I want to check my queries, and other people, if I have more than 10 queries today that are more than 1 terabyte. So you can just create these log-based metrics, create all these alerts on top of that. You can even route all the metrics to just one admin project who is using different things, and have all these alerts centralized. So super useful for letting people know about different scenarios and events in your day. And the last one was just like the same. You can use cloud monitoring to create these alerting policies and use that for doing different actions. And the last one is just like my custom solution, kinda. I mean, I did this because I had like one problem. Like, all this BigQuery monitoring thing and GCP thing is super useful, but it doesn't go down to the level where I wanted. Like, I wanted to check my cost at the pipeline level, at the action level, at the table level. So I was trying to find a solution for doing that. And this is what I used basically. I was using FinOps data from pipeline that was querying the information schema tables. And with that information, and also using some information from the data from API, I was just merging everything, having all this information at the pipeline level, which was the most useful for me. So I can know if this pipeline is good, that pipeline is not good. And I can just monitor everything super fast, super easy, and let also developers have access to these tables so they can just check if they're doing fine or not. That was super important, super useful. And I'm going to do like a quick demo after this, so just stay tuned. And a few alerts that I was using on top of these tables I built, doing some statistical analysis using the CS score. Basically, I was just erasing alerts if I have like some outliers, some anomalies that were above, for example, 2 times my standard deviation that I was calculating in these tables. Doing also per pipeline budgets, like I want my orders pipeline to not spend more than 1,000 per day. So I can just raise alerts and do actions based on this cost per pipeline using these tables. I'm using some other models, like for example, Ariba Plus in BigQuery ML, that is very suitable for production, in my opinion, because it takes also into consideration the seasonality and all these trends that the data might have in the future. So very cool and very useful for trying to predict everything. And also apart from that, you can also enable the big billing export to BigQuery. Do you have all the GCP billing centralized in BigQuery, and you can use that along with this per pipeline data to just have everything there and have everything in a Looker dashboard, for example, or in a Looker Studio dashboard, which is also super useful. And I would just encourage you to just do both and merge everything there and start playing with the metrics and the dashboards. Just one extra point, also use labels for trying to allocate costs. Super useful also for auditing things and stuff. It's just super easy, and also most of the people are using labels, so you can just label it this table, it this job, it this whatever is from one team or the other. So FYI, you can also use this. And just the last chapter is to talk about the FinOps culture, basically. Like I found a lot of benefit from trying to make this clear to devs, like giving them all this information, all this per pipeline billing data, everything, and trying to set up like some dynamics, kind of Hall of Fame, like doing like some gaming with this. Like I got all my dev environments, and all the devs are just using these environments to build things and enhance the code and adding new functionalities. So they can just go to my dashboard and check everything and check if they're doing fine or not, if they need to be better, and they can just kind of compete against each other to make the best pipeline. I found like that very useful for most companies, and devs usually takes this into consideration and start working better, in my opinion. Yeah, that's it. I'm just going to do a quick demo and show you my solution, my FinOps dashboard. Okay, so this is a dashboard. You have different sections, general data for additions. I'm going to walk you through all of them. The first one is the general one. You have here the first tab, which is BigQuery cost. This is like more thing for upper management people where they can just see all the costs in BigQuery split by environment, by type, everything. You can just go here and filter everything, select different time periods, different environments, etc. So people can know where are we spending the money and why, basically. The storage info is basically all the info we have about the storage that we get from the storage information schema tables. Here you can just realize if you need to switch to physical model to logical model, if you're fine, if you're not fine, if you're spending too much money, etc. You can also here check if the partitions are going up by a lot, and you need to maybe do some expiration, like expire some partitions, for example. You can see also here, for example, how the cost is going up or down with time regarding storage, your most costly tables, everything is just centralized here. Then you have the user queries info. Here you will have all the info about people using queries against your tables, against your data warehouse. So you can just know if some people are just doing it fine, or maybe they're just doing wrong, doing too many select all, and they're spending too much money. So you can just know how much we're spending per query per day, which people are just doing like the most damage, if they should change something, if they're fine with that much cost per day. So all the stats are here. You can just also here check what queries are they running, etc. Super useful. Then we got the data form section. Here you have the cost at different levels: pipeline level, action level, and jobs level. Pipeline is like the upper level. This is basically the data form tag. Like every time you run a data form tag, I would consider that as a pipeline, because those are like all the actions that run together, that all the data you're processing in one step. So here you can just see all the costs split by those pipelines. Super useful for devs, that they can just add a new feature, add a new join to a pipeline, and just go here and check if the cost is going up or down, if they're doing better or not, if it is just taking longer or maybe less, if they need to change something. Because when you go to the BigQuery billing, to all these tables, you will see all that information at the BigQuery level, which is not super useful for devs, because devs want to see the cost split by real pipelines. So for example, if I add a change to the inventory pipeline, I can just go here and check if we're doing better. If I did a spike, for example, I can just filter to just use my environment, the test environment, because I'm just doing some tests there. So super cool, super useful for devs. Then if you want to go deeper, you have the action level. Basically, a pipeline has different actions, and here you can see which action is doing the damage, if some actions are just going up in time and increasing the cost, or not, if maybe your change to the inventory table, whatever, it's just not good enough because the cost is going super high and you're modifying more partitions. So if you want to go deeper, this is your tab. And then if you want to go even deeper, you have the job stats here. One actions can have different jobs. And here you can just filter every job, checks for jobs that I'm doing select all star, for example, check for jobs that I'm querying one table, check if one job is modifying too many partitions, for example. So also super useful. Then some stats about the most expensive actions and pipelines. So you can just have here in one tab everything, and here is super useful for letting people know which are the things we should tackle first. Like we should go first to enhance this pipeline because it's maybe 60% of the entire EDP BigQuery costs. And then the pipeline depth analyzer. Here you can just let users, let devs to go here, introduce their workflow ID that they can get from the data form workspace, and then check every cost here, every stats here for their workflow ID. Like here, if you enter your workflow ID, it will compare your workflow ID to the latest executions of your pipeline, of that pipeline. You can select here different time windows, and you can know if your execution with your changes is just doing it better or worse, if you're spending more money or not. So super useful. I would say this is the most useful tabs for devs to go here and check if they're doing fine. So we prevent spikes to go to production and we catch them early. And the last section is the additions. We have two sub sections here: pre-migration and post-migration. Pre-migration is basically for letting you know if you should switch to additions or not, or if you should keep on demand at the pipeline level. So again, super useful. When you try to decide this, you always go to the project level. But since you can do like some reservation topology, you can just do some dynamic assignments. So this is super useful for doing that, for combining with that thing I mentioned before in the theoretical part. you can just have that this and that, and know if orders, for example, should migrate to a standard mode, because that will save you some money, like, I don't know, $1,000. And you can also use here to compare different scenarios per day. Like, for example, with this, you will know if customers, for example, pipeline is just better in the standard than in on demand. And for example, nowadays, it's just being more costly because any reason. So there you have it. Same for the here at the project level. So you can just compare different scenarios for your project and let you know which one is better. Super useful. And the last thing is the reservation cost analysis. So this post-migration tab, whenever you reserve something, whenever you switch to editions, you can just check here if you're doing fine, if your editions are just spending the right amount of dollars, if your slots are scaling fine, if you have some problems, if you maybe need to go back to on-demand. Everything is centralized here. You can just pick the best for you. Yeah, that's it. Thank you so much for listening. Just let me know during the QA live if you have like some questions or something.
Wow. Well, thank you so much, Pedro. That was really, really awesome. A lot of really great information. And I'll say, after everything that we saw today, we went through a lot of the capabilities of BigQuery, new stuff, how to make sure that we're correctly thinking about our architecture and scaling. And to see the breadth of information in that presentation was crazy. And I'd say maybe for some people, overwhelming. So I know there's one question that I want to ask you that I think we could say, let's say somebody's been asked to come and participate in your presentation because they're big users of BigQuery, but they want to start to get their hands around what's going on with cost. So we have time for one question like this. So I think it's really important if somebody is getting started and they've never thought about BigQuery cost before, what's the biggest area, the most important area they should dive into to start to optimize and understand the situation?
Yeah, I would say you need to first work on visibility. That's like the main point when you start. You just need to make everything visible, all the different stats, both at the project level, at the resource level of BigQuery, and if you want to deep dive, like for example with dashboard show, at the pipeline and action level, that will be key. Like you need to know which pipelines, actions, tables are like causing all this damage, as I said. So that will be to me the key point, the start in all this FinOps thing. And then if you ask me, for example, for the main things that most company do wrong when I join them, like for example, when I try to enhance something in a company, I would prioritize clustering and partitioning. Like that can be around 60 to 80% of the entire cost. If you just do partitioning and clustering properly, then you're going to save a lot of money. Yeah.
Okay. No, that's really, really helpful. And I think I think after seeing that, obviously we're gonna share the recording, and you've shared the resources, including your dashboard, by the way, which is really awesome. We could sit here and talk for hours about it. I'm sure about the different ways to optimize. But I really appreciate your session, and I think I speak for everybody. It's an honor. It's been great information. So thank you so much, Pedro. And
Thank
we're
you,
going to
everyone.
move into